Hello, everyone. In this video, we're going to look at question number 7. It says, in the process of a medical procedure, a technician injects a small amount of a radioactive material into the patient's bloodstream. The amount of the material remaining in the bloodstream in milligrams per milliliter T days after the initial injection is approximated by the following function. C of T equals 1/3 parentheses 3T plus 3 close parentheses to the negative 1/2 power. Find the rate of change of the mineral level with respect to time when the initial injection is administered, in other words, after 0 days. In other words, when T equals 0. So we want to find what is the initial rate of change, basically. Now, rate of change, of course, should tell us derivative. So I need to take the derivative of this expression. Now, that means that I need to go ahead and use the power rule first, then the chain rule. Negative 1/2 times positive 1/3, so C prime of T here. Negative 1/2 times negative 1/3 is negative 1/6. Then parentheses, just rewrite the base, which is 3T plus 3. And subtract 1 from the exponent, so negative 1/2 minus 1, type it in if you need to. That gives you negative 3/2. Good. So I'll just use the power rule here. Brought that down, multiplied, subtracted 1 from the exponent. Now I need to multiply by the derivative of the base, which would just give me 3 here. Now, negative 1/6 times 3, of course, is just negative 1/2. So this is negative 1/2, parentheses, 3T plus 3 to the negative 3/2 power. That is our derivative. But we specifically want it to have, or we specifically want to look at this as, or at time T equals 0. So I want to find what is C prime of 0 here. So it'd be negative 1/2 times 3 times 0 plus 3 to the negative 3/2 power. And then we can just go type that in. So here on the home screen, let's type it in. Negative 1/2, parentheses, 3 times 0 plus 3, close parentheses, raised to the negative 3 divided by 2 power. Enter. Now, let's go ahead and go to 3 decimal places. That makes that negative 0.096. Now, that's the number. What are the units? Well, the units for C is milligrams per milliliter. So it's milligrams per milliliter. And the T is in days. So per day. So those are the units. So it's negative 0.096 milligrams per milliliter per day. Good deal. That's A. B says, find the rate of change of the mineral level with respect to time after 2 days. So it's the same thing. Find the rate of change after 2 days and include units. Now, notice that we already have our expression for the derivative because that's what we want for the rate of change. Wonderful. So looking through here, we want to find C prime of 2. So it's just negative 1/2, parentheses, 3 times 2 plus 3, all raised to the negative 3/2 power. And we just go type that in. Now, I'm going to do a little trick here. Second enter means I can just type in exactly, or we bring in what we just typed in. I'm just going to replace that 0 with a 2. And so to 3 decimal places, that's negative 0.019. Good deal. And the units are exactly the same here. Milligrams per milliliter, and then per day. Good, that's B. C says, find the rate of change after 5 days. Same thing, rate of change after 5 days. So here I just want to find C prime of 5. So it's -1/2, parentheses, 3 times 5, close parentheses, plus 3, close parentheses, to the -3/2 power. And so let's go type all this in. And again, I'm just going to do second enter. And then replace that 2 with a 5. So again, to 3 decimal places, that's -0.007. Milligrams per milliliter per day. Good. So there's A, B, and C. D is asking us, what does the sign of these 3 answers indicate about the mineral level in the bloodstream? It's not wanting to know about the numbers, but what is the negative telling us? Because a negative is the rate of change that we're looking at, and it's negative. It means that we are decreasing the mineral level concentration, basically. So D is basically says that because it is negative, the mineral level in the bloodstream is decreasing. And there you go. That is question 7. Have fun.